Assalamualaikum and hi everyone. So I'm going to explain the differences between KERMA and absorbed dose. Firstly, KERMA is not equals to absorbed dose. By definition, KERMA is energy transfer per unit mass, whereas for absorbed dose is energy imparted per unit mass. The unit is both the same, joule per coulombs. And then the second formula for the KERMA, or second way of measuring the KERMA, we can use the energy fluence times the mass energy transfer. Whereas for absorbed dose, fluence times mass stopping power, okay, or mass stopping power for collisions. And then number two, the differences between these two. For KERMA, it is coming from energy is coming from uncharged particles. It transfers energy to the charged particles, so that this charged particle can be free from the atoms. Whereas for absorbed dose, it is actually the energy loss by the charged particles via collision loss. So the differences, energy is coming from uncharged particles to charged particles, and for absorbed dose is energy loss by the charged particles. It's been characterized by a mass energy transfer coefficient for KERMA. That is why we can measure from here. And for absorbed dose, characterized by collision stopping power. And then for KERMA, how we measure it, it counted for all energy, including the energy that leaving the volume, whereby for absorbed dose, we only counted the measurement for energy that been deposited within the volume. So energy that been deposited outside the volume must be excluded from the measurement or calculations. Then we go to the relationship between KERMA and dose. This is where we can relate between KERMA and dose by using the exposure. Well, you can see that K collisions air equals to exposure times W over E. And for dose in air also equals to KERMA collision in air by exposure times W over E. We can relate these two only when the measurement is taken in air and in the condition of CPE, charged particle equilibrium. Next, I'm going to explain using this diagram how we can measure or calculate the KERMA and the absorbed dose. Let's say I'm taking interaction by Compton effect, where the incoming photon 80 keV interact with single atoms, interact with orbital electron. It transfer 40 keV of its energy to orbital electron, and then another 40 keV is used to escape from the volume as a scattered photon. The electron or recoil electron takes that energy 40 keV, and then it was ejected from the orbitals, travels, and there are two processes happens during the traveling, which are ionization and excitation, and the other one is production of the Bremsstrahlung radiation. And then it was leaving the volume until it goes to rest. First, the KERMA happened at this point. I already explained in the previous section. This is the point where KERMA happened, where we get K total. How we calculate this K total? We have the energy transfer equals to 40 keV. Okay, so this is wrong. So KERMA is equals to energy transfer 40 keV divided with the mass. Let's say given mass is 1 gram. So just simply substitute the value 40 keV for energy transfer divided with 1 gram of mass. And then you change the value 40 times 10 to the power of 3, because this is K, and convert electron, and then convert gram into kg, and you will get the value. Okay, please correct the value because right now I'm using 30, so you have to make correct for this one. And then for absorbed dose, this is the energy transfer for electron. It lost energy 10 keV for Bremsstrahlung, and then it takes another 20 keV for excitation and ionization within the volume, and another 10 keV for ionization and excitation outside the volume. So total up, you will get 30 keV. This is for K collision. And if we take for Bremsstrahlung, K-rad, you will get, sorry, not K-rad, energy transfer for radioactive, energy transfer for collision. 30 keV, and this one 10 keV. If you sum up, you will get back 40 keV for total energy transfer. Right now, the absorbed dose is only counted for the energy transfer or energy that been absorbed within the volume. So we cannot count this energy caused by the electron of 10 keV. So we only counted from here until here, which is 20 keV. That is why the energy imparted with the volume is equals to 20 keV divided with the mass 1 gram. So after you make the calculation and conversion, you will get the dose is equal to 3.2 joule per coulomb. And you find that the dose value, when you compare with KERMA, dose value will be less than the KERMA. Why? This is because KERMA counted the energy inside and outside the volume, whereas for those is only counted within the volume. Outside the volume, we cannot include it into the calculation. Okay, I think that's all for the differences between KERMA and absorbed dose. Go back to your notes and read more about it. That's all. Bye.